Hey everyone, I decided to take a look at the Josephus problem with you. So, this problem is based off of an ancient story where Josephus and 40 other soldiers were captured by the Romans. The problem states that the 41 soldiers would be placed in a circle and that they would kill each other in a systematic way such that there would be one soldier left in the end who would then commit suicide. So, the soldiers would stand in a circle with a designated starting position. The first soldier would execute the soldier to his left, the next soldier would then execute the soldier to his left, and so on. This would continue around the circle until only one soldier remained. That soldier was then supposed to commit suicide. However, Josephus did not want to die, but rather to surrender. Where should Josephus place himself to ensure survival? Okay? And we could also look at this in a more general sense, for any size group. So first, we want to understand the problem. So I've got a circle here with 5 people, and we're just going to go through and think about the problem. So if person number 1 is starting, they would execute person number 2. Person number 3 then would execute person number 4. Person 5 would execute person 1, and then person 3 would execute person 5. So in this case, the winning position is the number 3 position. Okay. So with 5 people, number 3 would be the place where Josephus would want to place himself. Okay, so I think we've got a little bit of an understanding here of what's going on. So let's try to develop a plan. So we can simplify this problem with 41 soldiers and look at smaller examples. We can then look for any patterns that we might find in our table and see if we can come up with a rule. So here I've drawn the first 8 examples. And so if we look at each one, with one person, the winning position is 1. With 2 people, 1 eliminates 2, and 1 again is the winning position. With 3 people, 1 eliminates 2, and 3 eliminates 1, so 3 is the winning position. With 4 people, 1 eliminates 2, 3 eliminates 4, and then 1 eliminates 3, and so 1 is the winning position. 5 people we just did on the previous slide, and that was 3. 6 people, 1 eliminates 2, 3 eliminates 4, 5 eliminates 6, 1 eliminates 3, 5 eliminates 1, and 5 is the winner. Now at this point you might be looking at this and you might think you see a pattern here. So we've got 1, 1, 3, 1, 3, 5. So perhaps it's going to start over and go 1, 3, 5, 7. So let's take a look at the next table. We have 7 people. 1 eliminates 2, 3 eliminates 4, 5 eliminates 6, 7 eliminates 1, 3 eliminates 5, and 7 eliminates 3, and 7 is the winner. So we thought maybe it would start over again at 1. Instead, it went to 7. So we better take a look at 8 people and see what happens. 1 eliminates 2, 3 eliminates 4, 5 eliminates 6, 7 eliminates 8, 1 eliminates 3, 5 eliminates 7, and 1 eliminates 5. And now we are back to 1 being the winning position. So let's take a look at what we have so far. We've got our table here, N, and then S of N is the winning position, the seat that's in the winning position. And we have this table here. We're starting to see a pattern, 1, 1, 3, 1, 3, 5, 7, 1. We're probably going to go 3, 5, 7, but then maybe we don't know after that where we're going. So let's just take a look at some of these other ones here. We eliminate 2, and then 4, and then 6, and then 8. 9 eliminates 1, 3 eliminates 5, 7 eliminates 9, 3 eliminates 7, and it's just what we thought. 3 is the winner. Something else you'll notice about these values is they're all odd. So why are they all odd? Well, every time we're starting with an odd, and they eliminate the one after them, which will always, around the first time around the table, will be even. So if we have an even number like we do with 10 here, every odd preceding it will eliminate the even that follows. Okay. In the case of an odd number, okay, we just have that one odd that's left then at the end, but we've already eliminated all of the evens. So we know this is going to always be an odd number over here in our table. Let's finish this one up. 1 eliminates 3, 5 eliminates 7, 9 eliminates 1, 5 eliminates 9, and 5 is the winner, and our pattern continues. So eliminate all the evens, 2, 4, 6, 8, 10. 11 eliminates 1, 3 eliminates 5, 7 eliminates 9, 11 eliminates 3, and 7 eliminates 11. 7 is the winner. Now, we get to a situation where we've repeated this pattern before. We want to see what happens after 7. Do we go back to 1? Do we go to 9? So we eliminate all the evens. And now 1 eliminates 3, 5 eliminates 7, 9 eliminates 11, 1 eliminates 5, and 9 eliminates 1. So 9 is the winner. And now I want to start looking at something else in this pattern. So as we go around the table here, we eliminate all the evens. And after we do that, let's just look at how many we have left. So 13 is kind of like the new starting position now. We have 1, 2, 3, 4, 5, 6, 7. And if we go back to 7 in our table, the 7th position should be the winning seat. So 13 eliminates 1, 3 eliminates 5, 7 eliminates 9, 11 eliminates 13, 3 eliminates 7, and 11 eliminates 3. And indeed, that was the 7th number that we had left after we eliminated all the evens. Okay. Let's see if that holds here for 14 people. So we eliminate all of the evens. Now we're back to 1 for our starting position, and we have 7 left. So again, it should be the 7th number that's remaining. So 1, 3, 5, 7, 9, 11, 13. Okay. So here, 1 is going to eliminate 3, 5 is going to eliminate 7, 9 is going to eliminate 11, 13 is going to eliminate 1, 5 is going to eliminate 9, and 13 is going to eliminate 5. So for 14 people, 13 is our winning seat number. So you can see that we're always able to eliminate all the evens and then basically look back at a smaller example of what we have left and know exactly where that seat is going to be. So I'm actually going to jump ahead here to 16 and take a quick look at that and see what happens. So we eliminate 2, 4, 6, 8, 10, 12, 14, 16. Now we have 8 left. So the first person should be our winning seat. Well, 1 eliminates 3, 5 eliminates 7, 9 eliminates 11, 13 eliminates 15. Let's look at how many we have left now. 1, 2, 3, 4. Again, 1. 1 eliminates 5, 9 eliminates 13. Now we have 2 left. Again, we go back to our table, first seat. And then 1 eliminates 9, and 1 is the winning seat. So we have this situation here where we have basically the winning seat is 1 at 1, 2, 4, 8, and 16. Now we should all recognize those as powers of 2. So essentially when we get it down to a power of 2, the first seat will always be the winner of whoever's left. So how do we get it down to a power of 2? Well, we have to eliminate some people. So we have to think about, for example, 15 as 2 to some power plus b. Okay, and b is the number of eliminations that we have to make. So we want to choose the highest a possible. So 2 to the third plus b would be 8 plus b, which means b must equal 7. So we want to make 7 eliminations and then choose the starting position, and that should be the one that fits in this gap right here in our table. So we make 7 eliminations. 1, 2, 3, 4, 5, 6, 7, and now our starting position would be 15. So 15 should be the winning position. And let's just follow it through to the end. 15 eliminates 1, 3 eliminates 5, 7 eliminates 9, 11 eliminates 13, 15 eliminates 3, 7 eliminates 11, and 15 eliminates 7, and sure enough, 15 is the winning seat. Also notice then that that means that our winning seat is going to be 2 times b plus 1, okay? Where b, again, is this number we had to add on after we subtracted off the 2 to the largest power possible from our initial number. Okay? And that's, again, because we made b eliminations, and every time we eliminate, we move forward 2 spots on the circle. So 2b, and then the next one is our winning seat. So let's look at this for our case, 41 people here. For 41 people, it is 2 to the 5th would give us 32, and then we would have to add 9 more to get to 41. So if we make 9 eliminations, the next seat should be the winning seat. Or in other words, 2 times 9 plus 1. Seat 19 should be the winning seat. Okay? And you can go through that to verify that result. So 1 eliminates 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40 all get eliminated. Then 41 eliminates 1, 3 eliminates 5, 7 takes out 9, 11 takes 13, 15 takes 17, 19 takes 21, 23 takes 25, 27 takes 29, 31 takes 33, 35 takes 37, 39 takes 41, 3 takes 7, 11 takes 15, 19 takes 23, 27 takes 31, 35 takes 39, 3 takes 11, 19 takes 27, 35 takes 3, and then 19 takes 35. And 19 is indeed the winner. So one last thing then, we should look back and think about this. So we know we need to get to a point where we have 2 to the a people left, okay? Because at this point, the person who is currently in first will always be the one remaining, okay? Because we can always cut that in half. We can always renumber them, and we'll be able to get rid of those even numbers and cut it in half again and again and again until we're down to 2 people, in which case the first person is the winning person. Okay. So in order to get to this position, we need to eliminate all the extra people between 2 to the a and n. So we move forward around the circle 2 spots for each elimination. So the winning location has to be 2 times the number of necessary eliminations plus 1. Thank you, and let me know if you have any questions.